objectives here, perform calculations with specific heat capacity. So that's what we're going to do today. And then here's the definition. Now, again, this PowerPoint is in your modules. So the specific, and it's also, I also have it in your, I'll have to upload the book yet. I still haven't done 9.3. I did 9.2. I'm not sure I did 9.3. I'll have to take a look. All right. So specific heat capacity of a substance, there's a definition. It's how much heat's required to change a certain amount of that substance by 1 degree Celsius. That's called the specific heat capacity. And specific is because every substance has its own heat capacity. So it takes more heat to change the temperature of a piece of metal like iron than it does to change the temperature of a piece of glass. And it takes even more heat to change the same amount of water by 1 degree, to change its temperature by 1 degree. So if they have a high heat capacity, that means that it takes a lot of heat energy to change the temperature. If they have a low heat capacity, that means it's easy to change their temperature. Another example, like if I take a bottle of water, take a plastic bottle of water and put it in the freezer, it's going to take it at least 2 or 3 hours, maybe more, to freeze solid. If I take the same amount of V8 and put it in the freezer, and in 2 hours, it's going to be frozen solid, because of the stuff that's in the water lowers or decreases the specific heat capacity of it. So it freezes real fast, whereas the bottle of water still has a real high heat capacity and it takes a long time to freeze. So now, because now what I'm getting at there is I'm removing heat. So I can raise or lower the temperature of something, and the specific heat capacity is just how much heat do I have to add to increase the temperature, or how much heat I take away to decrease the temperature. So, and then the formula for calculating it looks like this, but this is in your book, and this is kind of, I don't know, to me, this is like annoying to look at. Some of you are like, oh, that's so elegant, I love it. But people, myself, when I look at that, I'm like, ooh, that's a little busy. So when I teach it, I'll go back to my, let's see, where was I? Right here. When I teach it, I use this Q equals, and I call it MCAT. M is the mass, C is the specific heat capacity, and this delta T, which is your change in temperature. Now, change in temperature, you take your final temperature and subtract your initial temperature from it, and that will give you your change in temperature. All right, now specific heat capacity will either be given to you in the problem, or you'll have to look at the table of heat capacities in your book or in the PowerPoint. So here those numbers are right here. Now this is, got to remember, this is in kilograms, joules per kilogram. I'll upload one in joules per gram degree Celsius. So I'll make sure you have those numbers before I turn you loose to work problems. Okay, do we have any questions so far? Okay, so look, when you see this, there's only, there's 5 things. 1, 2, 3, 4. It looks like just 4, but remember, change in temperature involves final temperature and initial temperature, so you can be asked those. And this first problem asks you for final temperature. So, so all you do is you got an equal sign. So if you got anything on the right, it goes underneath on the left. Does that make sense? And then you just do your math. You rearrange the formula and then do the math. All right, so so what I'm going to do here is, the way to solve this problem is rearrange this to solve for your change in temperature, and then your change in temperature minus your initial temperature will give you your final temperature. I hope that makes sense. It'll make sense when we do it. All right, so I need to get change in temperature by itself. So what I do with M and C, And divide both sides by it, right? So Q, which is my my mass and my where is I should have a should have okay. I don't think they're giving me enough information here because I need my energy. What is the final temperature when 3 kilograms of gold 99? Oh, okay. So I got my change in temperature. So I just got to, okay. Oh, goodness. This is way, okay. I am not going to have you do a problem like this at this point. That's an AP level problem. Sorry about that. I should have read it closer. Let's go to the next one, see if it's going to be, oh my gosh. All right. The only thing I want you to take out of this is this part right here in MCAT. I'm going to change gears here. This is, remember I said a while ago, I'm skipping section 2 because the problems are kind of a pain. This one is a 2-part problem. You got to divide the water into one problem and divide the metal into another problem. And I am not going to put you through that. So I apologize vociferously, and I'm going to change gears. Let's see. Let's go to this one. Nope, let's go to the other one right here. Okay, I'll go to this one. All right, so I'm going to let you fill this stuff in, and we'll go work a couple problems here, and then I'm going to turn you loose on this worksheet. All right, pardon me as I change gears here. Wow, that was a train wreck. All right. What's the temperature in which it's from section 1, all molecular motion ceases? What do we call that temperature? Come on, guys. I'm feeling like I'm a failure as a teacher. You just had a quiz on this. Gave you the first 2 letters.
Absolutely.
Okay. All right. So the first one here is what? That's what today's lesson's about. That's specific heat, or you could say more specific heat capacity. Okay. When energy is absorbed, what are we doing to it? Begins with an H. Ends in ing.
Heating.
Yes. Thank you. Thank you very much. And the opposite of heating is?
Freezing.
Well, you're on the right track. Let's use a different word, even though that's correct. Begins with a C. There you go. Cooling. Awesome. All right. So I'll let you guys fill those in. I'm going to upload this in a little bit. I just haven't. Okay. All right. So I'm going to go through and work this problem. What is the specific heat of a substance that absorbs 2,500 joules of heat when a sample of 100 grams of the substance increases in temperature from 10 degrees Celsius to 70 degrees Celsius? All right, so this is a straight up MCAT problem. So remember, let's go this way. Come on. Need to get some space. Give me some space, man. All right, so Q, which is your heat in joules, so that's right here. This is Q. Okay, this is M. And this is delta T. Okay, 70 is T final. And 10 is T initial. So 70 minus 70 minus 10 equals 60. Okay? Q equals MCAT. It's unlocked. Yeah. All right, so all you do now is what do we want to solve it for C. So you lose it? Oh, okay. Just sit there. They don't give those away. Really? I'm teaching here. And I'm recording. $2. They cost me more than that.
Do you take Apple Pay?
Apple Pay? No.
See if tomorrow was
So, goodness, I feel bad.
Do you take Cash App?
Oh my gosh, some people's children. All right. As I said before, so rudely interrupted. We take this and solve it for little c. So I'll just do it this way. Q, it's just going to be Q divided by anything over here that we need to get rid of. What is it? We need to get rid of M and you need to get rid of delta T, right? So that's all you do for these. Okay, what's M? 100?
60.
And 60. Okay, so 2,500. Okay, what happened here? 2,500 divided by, what is that, 6,000?
42 if you want it to.
Did my math right there, right? Okay, so that's, was that 0.41 or 0.42? Now that's joules, because this is joules per, what's my mass? Grams. This is degrees C. So joules per gram dot Celsius degrees. All right. So is that just like, oh my God, I can't do that? Or is that, oh, that's not too bad? I'm hoping it's the latter. How we doing?
We can do it.
All right, so let's, there's specific heat. Okay, so then there's heat energy, so that's Q. You guys, I mean, I'm thinking most of you right now are ready for me to just turn you loose on this. Am I right?
Yeah.
Correct or not?
Yeah.
All right, so I'll stop recording and upload it. And what's that? Yeah, you want me to print you one? Yeah, no problem.